Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
And good evening again, everybody. Thank you for joining me. And tonight I have a many different topics. So the last few weeks I've been concentrating on atmospheric electricity, and that's a topic that always will pop up almost no matter what you're talking about. That will somehow weave into the conversation. It is so prevalent in our weather, in your own being. For example, we are all connected in some way to the vertical electric field. And what happens is if you go outside, especially in the summertime, you stand in the grass in the morning time when the dew is there, the dew has fallen, and your feet then connect electrically to the ground, and people say that makes you healthy. That can alter your state of health, etc. And there's a reason for that, because you are an antenna. For example, there's all kinds of things. Now, I'm kind of digressing from my main topic tonight. But, for example, when you meet people, there is an electrical connection, a magnetic connection, and there's a term. It's called vibes. People giving off vibes. So there's kind of a slang term for that, but the reality is that yes, you are connecting. Your body is like an antenna. It's giving off signals and it's receiving signals. And I've talked about this before when especially for younger people, and this is why I really don't agree with things like dating apps, because there's literally a connection that people make when they first meet. And it's hard to explain, and this is part also dealing with your spirit. Your spirit's connecting, and on that dating app, there's all of that is completely removed. But I always give an example. You're going about your business, you're busy one day, all of a sudden you walk around the corner and you bump into, like a guy and a girl bump into each other, and they're like, it's like destiny maybe, partly, but also it's like they all of a sudden, people talk about love at first sight, for example. That is very much a connection between the two people. And they are, it's not only physical, but it's like all kinds of attractions going on in between the spirits, between the electromagnetic part of the body, the antenna part of the body, etc. And so this is something very real. This is why last week I talked about the shamans in Peru going up into the mountains. They go barefoot. And so you see these people, and they have a callus on the bottom of their foot. It's like walking on a piece of leather. But they are connected to the ground, and then they go up high in the mountains so that they can connect to the vertical electric field. Their body does. So anyway, the end result is that it's important to understand the influence that the vertical electric field has in our bodies. And, for example, the moon contributes to this. And this is why, like, if you talk to any sheriff or law enforcement officer, they will tell you that during the full moon, they hire extra people. They get extra people on the staff because they know that the crazies are going to be out, and there's something to that, like the old werewolf movies, talking about the creatures that come out and start growing extra hair on their in their knuckles, at midnight when the full moon is out. We just had a full moon here, interesting one, a red moon, orange red moon. But anyway, back to the story. The moon is electrically charged because it's out in the solar wind. It's discharging the solar capacitor. NASA has taken a picture of its sodium tail. So the moon sports a tail like a comet tail. And the reason is because it's discharging the solar capacitor just like Earth is. But the moon does not have a protective magnetic field. So it's kind of like raw out there in the solar wind, much like a comet nucleus. So I'm getting a little bit off track here, but the point is that when the moon is aligning with Earth, there's actually an electrical connection there between the moon and Earth, where there always is a connection, and it's one of the driving forces for our magnetic field. Anyway, these rather complicated issues, but the point is that it affects people. And when there's a new moon also, there's another electrical alignment, but it seems that the full moon has more effect. And in fact, there are biological systems, especially in the ocean. And actually any place, like people and animals are affected by the state of the moon, the phase of the moon. Okay, so anyway, I'm not going to go into that. Just other little note on that. When I was working with these Russian scientists at the University of Novosibirsk, and they were atmospheric scientists, dealing with like tornadoes on the sun. I talked about this last week. As the daily meetings went on and they were translating my work into Russian and understanding the electrical nature of the solar system and of Earth and weather systems, etc., the psychologists at the university got wind of this and started sitting in on the daily meetings. And so the reason they were interested is because they had been measuring the effects of what they did is they had unborn babies or fetuses that were still in the mother, and they had electric probes on them to see what kind of reactions that the babies would have as they were developing, and then also when they were born, when all of the senses kicked in for the first time. And so what they realized is that there was a correlation between activity of the babies and the alignment of planets, electrical alignments or physical alignments, not visual alignments, but physical alignments of the planets. And so they thought it was gravitational, but it turns out that we are gravitationless relative to the other planets. And that's something I've talked about before on this show. But what they were interested in is the fact that the babies were acting like antennas, and because they were in the womb, they really had no interaction with the sight. They could hear things, but they were picking up on the signaling from the positions of the planets. And they realized when they were born, all of these senses kicked in on the little babies, and all of a sudden their reaction to the planetary alignments was lessened because they had all of this other input coming in from the senses. And it turns out that people, as they age and grow up, many of them lose this connection, or they become less aware of it. And so it really, I could go into a lot more detail, but it gives the physical basis, a basis in physics for what we call astrology, the reaction of people to the positions of the planets and also to the stars, because that gives us a frame of reference, the stars, in which the moon and the other planets are interacting electrically. So at any rate, I kind of got off my main subject there, but I wanted to talk about I just wanted to go into a little more depth, and maybe a couple shows in the future I'll go into a lot more detail on this very topic. But the point, going back to the point of human interaction is that if you're in a room full of people and they are like-minded, there's a vibration. Or if you go to, say, a great example is like a concert, whether it's a opera or a rock stadium full of teenagers, and that connection where you have all these people together, it's like a magnification. I heard a guy just talking the other day. He was at a Paul McCartney concert, recent concert of one of the Beatles, Paul McCartney, and he said that the feeling in the crowd was just tremendous energy. And he said he actually started crying a little bit because of the amount of energy that was exhibited in the just the collection of people there. And there it is. There's an expression, soul music. And of course, this comes out of the Bible Belt in the South, and related to music that developed in the churches, religious singing, etc. And then it grew into popular music venues. But there again, when they say soul music, it comes from the soul, the heart. Some people think that the heart and the soul have a lot more to do than your brain. So we have these different aspects to human beings that are not measurable. You can't put a meter on it. As a physicist, we always love to have things where you can put a meter on it, or put a microscope or some kind of probe or whatever, and look at only the physical aspect of that, whatever it is. But in reality, that's what makes humans different than the monkeys out there in the jungle, is that we have a soul, we have a spirit, and that makes us us. Different than, say, just animals who every male lion acts like every male lion. They respond, they react to their environment. But they don't have an individual spirit like human beings. You don't find whales doing quantum mechanics. You don't find dolphins developing space probes. They're locked into what they're doing. They eat fish, they swim. That's what they do. And so anyway, I think it's important for people, especially young people, to understand that they're individuals. They're different than everybody else, and they're different in good ways. If everybody was the same, like the monkeys out in the jungle, that's what they want to teach you in school, by the way. This has been one of my things I've really been very aggravated with in education, is by the first day the kids walk into kindergarten, what are they teaching them? That you're like a monkey. They show them that picture of the evolution of man with the monkeys crawling and then standing up, and then eventually there's man. No, believe me, that's not the way it is. Man has been on this planet in developing in his current form for a lot longer than they would like to tell you. It's not like we just crawled out of Mesopotamia 7,000 years ago or something, where the first man developed in all the various varieties of man. I don't like the word species. That's really a terrible term, very misused, very misunderstood. But all of the, let's say, varieties of man, the short, the tall, the different builds, the different eye color, skin color, whatever. And by the way, people talk about people of color. Isn't white a color? Everybody, I'm so tired of people trying to identify with all of these external characteristics. And what we should always be doing is just dealing with who the person is, what are they like, and interact with them that way. Anyway, I'm getting off subject here. I want to jump out to something that just popped up in the news. There's a telescope that just went up. It's owned and operated by the European Space Agency, and it's called Euclid. Of course, named after the Greek Euclid, who did a lot for mathematics and logic. And okay, so at any rate, this telescope goes up, and it's a very capable telescope. I mean, it has super resolution, extreme high resolution, and it scans the entire sky. So it's not just looking at one thing, taking a picture. It's doing a scan of the entire sky and giving back the data. And it's in the visible and the infrared. So that's the light that we see with our eyes, the visible spectrum, and then the infrared, which is what a lot of animals see. They can see at night. They have night vision, you call it. And we have a little bit. We have a little bit of infrared capability in our eyes. If you're in a dark room at night, or if you're outside, and you look at something and it's pretty dark, don't look right at it. Those are the retinas for your visible eye. Look a little bit to the side and you'll see the object much better. And those are the infrared parts of your eye working. But it's not very good. It's not like an owl or a cat or dog who can see very well at night with infrared. It's the next step of light to the longer wavelengths. Okay, so at any rate, this telescope is amazing. And so what it's doing is mapping the entire sky. But here's the problem. This telescope time is being occupied by people who believe in, I'll go through kind of a litany here, that things that are completely bogus science. And we know it, we've known it for decades. So like the Big Bang, totally bogus. And if you believe that the universe popped out of a pinhead 13 billion years ago, then you're a pinhead. It's the most ridiculous thing. I try and give people simple examples. Imagine your house where you live, and you look at it and somebody comes up and says, you know, your house just popped out of a pinhead one day. There was no design, there was no designer, there was no, all the material, all the boards, all the nails and everything just popped out and just assembled the way it is all by themselves. And, would you believe that? Well, you'd think I was out of my mind. What a crazy guy trying to tell me that my house just popped out of a pinhead. No. And they're trying to tell you that the whole universe, with all its organization and all the physical properties that are the same on the far side of the universe as they are here, that it just all popped out of a pinhead one day. All the matter, and it developed, and they know all the theory on how it happened. Oh my goodness. And these people are pawning this off. But then, when it doesn't work, when they look at the actual data of how things are distributed in the universe, and things are not distributed the way they think they should because of the theoretical model of the Big Bang, then they invent something called dark matter and dark energy. Something you can't see. We can't define what it is. We don't know where it is. We can't see it. But it's got to be there because that makes our theoretical model work. Now, if you believe that one, I got a bridge to sell you. These people are milking the government funding operation. And the problem is, here's one of the big problems, is the news media is complicit. Now, let me just explain. Now, in a real world, this wouldn't happen. In a real world where somebody had to produce real results and actually put bread on the table, as the expression goes, this wouldn't last a New York second. But it's big money. Where does the money come from? Well, it actually comes from you. Through your taxes, you pay for the government-funded science. And so what does the news media have to do with this? Well, they're pumping the party line because guess what? They make their money when they report the news. So anyway, what I'm going to do is pull up this article here, and I'm going to read a little bit. This comes from, it's called Science Alert. And this article would probably be, it looks like it came from another source, but it's not clear. It's called Universe Today. And then there's another reference to space. So I don't know if that's space.com. But anyway, all of these magazines play to the same genre. And I'm just going to read this to give you a flavor of how news media covers for bad, ridiculous science that you pay for and keeps these people. The problem is this amazing equipment could be used by people that have alternative ideas. Okay, so I'm going to read here. The ESA's Euclid Space Telescope has already wowed us with some fantastic images. After launching in July 2023, the telescope delivered some stunning first images of the Perseus Cluster, the Horsehead Nebula, and other astronomical objects. Now the telescope has released its first images of 3 deep fields. So this is they talk about the camera, and it says Euclid features a powerful 600 megabyte camera. It's MB, capital MB, so I assume that's megabyte camera that can take detailed images of objects like the Horsehead Nebula. However, its main job, listen to this, here's the punchline. However, its main job is to probe the history of the expansion of the universe. There it is. They've already decided before this thing goes up there, before it takes a measurement, that it's going to probe their pet theory, the expansion of the universe. Now it talks about a little bit about the operation of the camera. But then it says deep field observations can teach us a lot, as the Hubble showed, and are essential for uncovering how dark matter, there it is, the magic word, how dark matter is distributed throughout the universe. Euclid's deep and wide fields will provide the deepest and most detailed views of the universe yet. So there it is. This is what really, it's bogus science, but it's funded. Now, I could go through a literal litany of government-supported science that we knew 20, 30 years ago was bogus. Let's talk about comets. Comets are not dirty snowballs. Every article you see in the news media talks about comets being dirty snowballs. Little icy wanders, ventures, meanders from afar, little ice balls, that melt near the sun. Absolutely absurd. Or the Big Bang, or dark matter, or dark energy, or that hurricanes are formed from warm water. I could just go on and on and on about this, the absolute absurdities that are being pawned off on you, the public. And that's one of the main things I try and do on this show is educate people, and hopefully at a certain point. Now, see this article that I just read. What is it doing? Well, it's a yay rah rah, standard science kind of mouthpiece. But what's it doing? It's making it okay with you, the public. Now, there's people that you can find, like, say, just to pull out a name out of the hat, Eric Lerner. He's the head of the Fusion Lab and a physicist, high-energy particle physicist. And he's, for ages, have been saying, no, this Big Bang thing is completely bogus. There are thousands of high-quality physicists around the world who are repeating the same thing. Some of them try to point out the plethora, absolute monumental amount of data that is in opposition to the Big Bang, and says, no, any one of these points would dispel the Big Bang as any kind of competitive theory. Yet, it continues. And why does it continue? Because the way government funding works is it's top-down. The funding is decided by the people at the very top of the pyramid. And how do they get there? They work their way up slowly. Okay, so they go to graduate school, they get a PhD, they get a postdoc, and then they get their first job, and then they work their way up, and after being in the physics world for a while, and if they're recognized and have published papers, which is their ticket to ride, basically, now they get into a position where they can start recommending funding, get on government panels, etc., to recommend where the money goes. Well, just, the water flows downhill. And so, who are they interested in funding? Well, the institutions that got them where they are today. And that is why government science cannot change. We've been going through this for 50 years. When I was at Cornell in 1979, I presented conclusive data that the Big Bang could not be correct. And it was, it was well funded, let's put it that way, back then. It goes back over 100 years. And let's just look at the basis for the Big Bang. The first thing that came out, the thing that really got it going, was Edwin Hubble around the year 1905. He was able to put spectrometers on a good telescope. He was the first person to actually see galaxies. And then they had spectrometers that they could put on the telescope and take the spectrum. And so what they noticed is that the common elements that we have spectral analysis in the laboratory to know the spectral lines and exactly what frequency they're at, everything was shifted to the red, no matter which galaxy you looked at. And so they go, well, what's going on here? And so they had Einstein's special theory of relativity, which predicted a red shift if something was moving away from you. So they look around and they go, well, everything around us is moving away. So that must mean the universe is expanding. That's where it got its root. What they didn't realize was that there's another source of redshift for fusion-based objects, and that's something I actually discovered. It's called the induced electric dipole force. What happens, and this goes back to the concept that the fusion objects have a stellar wind of excess current of protons, and there's a wind that comes off the fusion object, and it produces a non-uniform electric field, and that is what causes the induced electric dipole to occur in photons. And so it has to deal with fundamental physics of the photon. It has to do with the large-scale cosmological situation where you have fusion-based objects. That would be stars, stars, galactic nuclei, entire galaxies themselves giving off a redshift. And so then what they did is they interpreted the redshift. Well, the more the redshift, the farther away it is, the faster it's going. And you can show that the redshifts, the sun has a redshift at its edge. It's not speeding away at the speed of light or some amazing velocity moving away from us. It's pretty much a constant distance from Earth. Yet it shows a redshift. And I could go on and on about all the data that exists. And there's ongoing research now showing that, and this has been going on for ages, a guy named Halton Arp was instrumental in pointing out, he studied galaxies and did the, of course, spectral analysis of galaxies. And he showed that these quasars, very high redshift quasars, are connected to local galaxies. And the local galaxy, of course, had a normal redshift. And they were physically connected in X-rays, in ultraviolet, in visible light, in infrared, in microwaves. You could see the connection. It was not fake. It was, and astronomers have a tendency that if it doesn't agree with them, they just sweep it under the rug. And so anyway, and there are dozens, like I say, that's just one example of contradictory data that would disprove the Big Bang. But because of the government funding and because this is big money, we're not talking just little chump change here. We're talking vast amounts of money and the use of these pristine telescopes and the Nobel Prizes that are given. It is so ingrained in the monopoly. This is a form of monopoly, and you're paying for it. You're paying for it. And so the only way you can break this is to break the government cycle of funding. And try that. Now, isn't this amazing where you get fleets and fleets of PhDs all aligned in the same direction and controlling the news media, the scientific media, publications in peer-reviewed journals. And there's a complaint, I have it over on my other table over here, of scientists around the world who've been trying to publish contradictory data to the Big Bang, and they can't. It's being blocked from the peer-reviewed journals. And who's blocking it? The same people that are in line for the big funding. And these are big universities worldwide. This is worldwide. And these are the people that get the good equipment, they get the funding, they get the publication, and they're not going to let it go. So it's more political. It's not even political. It's a religion. It's a religion. And no amount of contradictory data will defer these people from their quest for maintaining their power monopoly. Okay, I'm going to read just a couple more paragraphs from this article. Pulling it up here, it says, Euclid, this telescope, Euclid will probably be the same. Its deep survey of galaxies will likely become foundational in our understanding of the cosmic web, dark matter, and dark energy. Once again, listen to this. Dark matter and energy are mysterious and are two of the most pressing issues in astronomical science. Only massive amounts of observational data can help scientists make headway in understanding dark matter and dark energy. Now, just to review, they don't know what dark energy or dark matter is. They don't know what its properties are. In fact, they don't have a single property of dark matter. They don't know. This is just bizarre. And like I say, the only reason they talk about dark matter is because their theoretical models simply don't add up, to put it bluntly. And so this is a ruse. This is a scientific ruse. And that's the best thing you can say about it. So, and I want to let the public know on this show, and that's what one of the reasons for this show is, to expose this science that is really, now this has been going on, like I say, for 50 years, this use of these amazing telescopic pieces of equipment. And there are other people who could use it to do real science. So anyway, I'm going to try and do my best to break this monopoly of government-funded science and open it up to other people, because if not, in 50 years, they'll be doing the same thing. They'll be still looking for dark matter. They'll be going, well, we're almost there. I could talk about other branches of physics that are doing the same thing. They've been looking for different things, like fusion. Fusion is a good example. It's like we build the next reactor, it's going to be, for sure we'll be able to break unity. In other words, gain energy. And it's a great misuse of government money. If there's no results within a few years, then people should go back to the drawing board. And as an independent scientist, the way science used to be is you had to produce results, and results that were usable and brought an economic benefit, and the economic benefit would bring a ROI to the investors. If you go back to the late 1800s, early 1900s, that's how science was done. That's how engineering came about. Edison made products. He sold them. He made money and reinvested that money into building more products. And so the same way with Tesla. When they developed a technology, they sold it, they took the money, and they were reinvesting that. And we have people today, Elon Musk is doing that. He's taking and privately developing technologies and innovation and making a profit and then reinvesting that money. That is a legitimate way to run science and engineering, including, but astronomy has gotten to the point, it's kind of like squirrels. If you had a squirrel in your backyard, in a family of squirrels, and you fed them every day, And they would, within a generation, they would forget how to forage for food. And that's what's gone on in science. I go to scientific meetings, like, say, American Geophysical Union meeting, and I have a sign on my badge with my name, and it says independent scientist. And people come up to me and say, what's an independent scientist? I say, I don't take government money to do research or do my work. And they're just like, how can you be a scientist without government funding? They don't understand because they're squirrels that forgot how to forage. Okay, I want to comment on the spring equinox, which just happened last Thursday, the 20th of March, and it typically ranges between the 20th and the 22nd of March. And the official date is the 21st of March. And that is when the length of the day is exactly equal to the length of the night. And so therefore the term equinox. And so it occurred at 4:01 a.m. Central Daylight Time, because we're on daylight savings time now. And at 4 o'clock, basically 4:01 in the morning. And that would, now as you move on, even the first minute or the first hour after that, already the daytime is becoming longer than the nighttime. And so we get to the situation where the farther north you are, if you're in the southern hemisphere, now you're heading into winter where the daytime is getting shorter because the pole is situated pointing away from the sun. But I want to mention that the Celts, going back to actually my ancestors, who developed a system of calendars, very effective system of calendars, started their springtime, like we start springtime on March 21st. That's the official first day of spring. And in terms of time, it would have been on the 20th this year at 4:01 in the morning, Central Time. But what the Celts did is they went halfway between the solstice and the equinox. And so December 21st is the official day of the winter solstice, and that is the shortest day of the year. And that's when the northern hemisphere is pointed away from the sun, spinning on its axis. And so what the Celts did is they said, no, the beginning day of spring is halfway between December 21st and March 21st. And so then the first, what we call the first day of spring, the 21st of March, would be the middle of spring, and then then we would be moving halfway between March 21st and June 21st, June 21st being the summer solstice, which is the longest day of the year if you're in the northern hemisphere. So you go halfway between March 21st and June 21st, and that would be the end of springtime for the Celts and the beginning of summer. So they juxtapositioned it by basically a month and a half. And that makes a lot more sense, but interestingly enough, there's a lag in the weather cycles. And so it almost turns out that if you put spring to a month and a half earlier than March 21st, we'd be in what we call winter. So it's not really the way it works out because of the wind patterns. And this brings up a very interesting situation. And this is something I say in my weather book, the Principia Meteorologiae, the physics of sun-earth weather, that the temperature doesn't depend on many factors, but for sure there's one major factor. If you're in the northern hemisphere, if the wind's from the north, it's cool, it's colder. If the wind's from the south, it's warmer. And that's something that you can almost bank on. If you look at the wind and the direction of the wind, that's going to control the temperature. That's what the temperature is linked to, not so much the other factors, even whether it's cloudy or not. The main factor in determining the temperature in a given place is the direction of the wind, because it's warmer in the south and it's colder in the north. And one thing also, when you look at what we call climate science. It's a very lazy science, where jokingly but actually realistically, what scientists did is they sat in their ivory tower office and they'd stick a thermometer out the window, and if it was warmer that day, they'd make a data point, and if it was colder that day, they wouldn't. That's about what it's like. But there's a lot of shenanigery going around in the world of climate science. For example, they will put the thermometer out at the airport. Well, guess what? You have all of that cement, and it's with an open field, and it typically is going to be a degree or two warmer at the airport than it is even downtown. And in downtown is going to be, in a city, is going to be warmer by a degree or something than the countryside, or if you're out in the woods. If you're out in the forest, it's going to be cooler. So they put the thermometer where it's going to be warmer. And so, gee, guess what? Temperature's rising. Yeah, that's true. But those are just examples of really bad science. And the issue comes back to the following, and this is going to aggravate a lot of people because it's what I call emotional science. People get emotionally attached to a concept, and if you try and tell them differently, it's like you poked a knife in their side. But the true situation is that the greenhouse effect, they talk about carbon dioxide or methane or other so-called greenhouse gases. Do you know what a greenhouse is? Let me explain how a greenhouse works. A greenhouse has a roof, and that's what traps the heat in. Of course, the sun shines into the greenhouse. It's called the greenhouse effect. The difference between that and the atmosphere is the atmosphere doesn't have a roof, a physical roof. And what happens at night? The atmosphere releases the energy into outer space every night. And even though you are driving huge amounts of heat directly into the atmosphere every day, where does that heat go? From a nuclear power plant, millions of cars driving around up and down the road every day. And you think, oh, that little bit of carbon dioxide coming out the tailpipe is going to cause a 0.1 degree rise in temperature in 20 years. That's the concept of the greenhouse effect. Or they don't talk about that anymore because real scientists will tell you that the greenhouse effect does not work. But the end result is that it does not trap heat like they're talking about. And if you couple bad science with a bad concept, you get typically a lot of government funding, and that's going away. Thank goodness. But here's the crux of the issue, and anybody there are experiments that show this, that if you take an environment, a closed environment, and you take two trees, exactly identical, grown from seed, the tree that's in the box with more carbon dioxide grows in proportion to the amount of carbon dioxide. The tree that's in the environment with only Earth's normal amount of carbon dioxide actually grows very poorly. And we have had times in the history of the Earth when Earth had very high levels of carbon dioxide, and it was the most vibrant time on planet Earth. And so the end result is we need not only more CO2, we need a lot more CO2, because the plants are literally starving of CO2. And what's going to happen? Now, a lot of these processes have feedback loops in them, and here's what would happen if you were able to have increase the amount of CO2 in the Earth's atmosphere. The plant life would respond and grow much more. The photosynthesis would the whole process would be augmented, and the plants would grow, and it would actually cool the Earth down. Right now, the plants are being starved. Look, we have huge amounts of desertification. If you start removing CO2 from the atmosphere, which people are doing now, it's going to starve the vegetation, and there will be a point at which there's a point of no return, in which you remove more and more CO2, and people think, oh, that's a great thing, get all that darn CO2 out of the atmosphere. No, what's going to really happen is that you are going to kill the earth. We need a lot more CO2 in the atmosphere. And I would say 5 to 6 times would be the amount of CO2. And what happens, that will actually cool the earth down, because you'll have vibrant plant life, which will shade the earth. And actually, if you don't believe me, walk into a forest sometime. You're out on a hot day in the summertime, and say you're down by a lake or something like that. Then you walk into the forest, or just walking on a path in the woods, walk into the forest, a dense forest, and it becomes cooler. Why? Because all that sunlight in the visible is being absorbed by the plants, and it's being converted into carbon dioxide-based matter. The carbon is being extracted, and you're releasing the oxygen. So you're building up the oxygen in the atmosphere, while you are taking the energy, the solar energy, and converting it into something. And that energy is, instead of going into the atmosphere and heating up the atmosphere, is going into plant matter. And the end result is actually cooling the earth down. We need more CO2. Not a little bit. We need a lot more CO2. So this fanaticism, this political football, this bad science, this I could go on. But the idea that we have to remove CO2 from the atmosphere is wrong. Completely wrong. And the thing we need is more CO2. Now, how do you get more CO2? There's a lot in the ocean. And there's a process by which we're going to start using the ocean for more and more things. In fact, if you get some of that CO2 out of the ocean and convert it into matter, and then release the oxygen into the ocean, the sea life would improve greatly. So there's a win-win for the improvement of the environment by releasing CO2 into the atmosphere. And I'm not talking just a little, I'm talking a lot. And you would see the earth green, it would cool down, and it would be a much nicer place. But right now there are people with machines, and I had a process that I developed myself for extracting CO2 from the atmosphere. It's part of a competition that I happen to be registered in, and it's highly funded, one of the most highly funded competitions on the planet right now, and a process to remove CO2 from the atmosphere. And what I realized is, yes, you can. And one of the goals was to remove large amounts of CO2, sequestering it from the atmosphere. And there's two types of solutions. One is to simply remove CO2 and put it in some kind of a medium where it will never be released. And the other one is where you take the CO2, you break off the carbon, and you release the oxygen. And that's a much better solution, because you are providing oxygen into the atmosphere, which you might think would be a good thing. But we have a lot of oxygen. That's not a big issue. Every day we burn oxygen. All the cars driving around, all the trucks driving around, all of the electricity that's generated, the majority is because of breaking down hydrocarbons and taking the oxygen out of the air to burn that, and we do that every day. There is a vast amount of oxygen in the atmosphere. But what is lacking is CO2. What we need is a lot more CO2. And not, CO2 is what we need, a lot more. And I would say 4 to 5 times the amount of CO2. Right now, the Earth has a 0.004% amount of CO2. It's drastically small. If people successfully sequester CO2 out of the atmosphere, they will simply kill the earth and the ability to grow plants. Okay, I'm going to switch gears a little bit here. I'm going to talk about computer security. Now, once again, just to give you a little bit of background, I spent 25 years of my life in the computer industry and networking at the technically high security positions and dealing with computer security, network security, encryption, computer protocols, and also when I was teaching in the university, some of those years I was teaching computer science and electronics. So fundamentals of electronics, things like that. So it's something I happen to know a little bit about. And I also was able to solve a 2,500-year-old mathematics problem to directly calculate prime numbers. And so that work I released to the public in 2007. And I wrote a follow-up book to that. It's called Breaking RSA Codes for Fun and Profit. And that book is, of course, available on my webpage also. But tonight I want to talk about something called SSL. SSL certificates and SSL. Socket layer protection. And so when you go to the internet and you'll go in your browser and you type in the HTTPS, that S there is an indication that the page that you're going to has a security certificate called an SSL certificate. Security socket layer is the term. And so anyway, the point is that you would think that gives you the impression that the page you're going to is somehow safe. And that is not the case at all. What the socket layer does is it sets up like a socket, like you plug a plug into the wall socket. It's the initial connection, and the idea is that it uses encryption to connect you to the page. The problem is the encryption they use is totally outdated and broken. And what is your real protection? I always give an example like this. That if you were marching down the street by yourself and there were a bunch of thieves on the side of the road, like there are on the internet, you would be vulnerable because you're the only person there, and all these thieves are there looking for you. And especially if you had a big wallet, you have a wallet full of money, or you have jewelry or whatever, you would be a prime target. But if you had 1,000 or 10,000 people walking with you, and all of the thieves were there, but you didn't have much money, you were not you didn't have a lot of value to you, the thieves probably wouldn't target you. And so that is your protection on the internet today, the fact that probably nobody's sitting outside your house right now trying to see if you're buying underwear on Amazon. It's probably not a top priority for hackers. The top priority for hackers would be if you had a corporation with millions of dollars of assets and records showing the credit cards of the people who have purchased from you, or business credit cards or whatever. That would be a target. And so anyway, what I'm telling you is that your best protection as you go on the internet is just being one of millions of people that are using the internet every day, and you really don't have any value. And of course, everybody has value in terms of buying potential. So they track you, but the SSL layer doesn't protect you from any of that. They can track you all day long, unless you have software in your computer that presents you as being anonymous on the internet. Okay, that's another entirely different topic, but what I want to talk about is, let me give another example here. Back in the old days when people would ride horses, there were people called highwaymen, and they would rob people on the highway, and they would sit off in a dark area or someplace where there was very little traffic, and people would come by and they'd rob them. And so it was a way of that's where the thieves hung out. And my opinion, and I'm going to just make this very clear that this is my opinion and it's shared by a lot of other people, including a growing number of people, and that's why I'm presenting this to you, is that this SSL certificate, which is very expensive, it actually in a lot of cases, it costs more to get the SSL certificate than it does to pay for the router or for the server time for the web page for the whole year. And it really doesn't do anything. If you're paying a bill to have a web page on a server, you're getting something of value. But the SSL certificate is like, if you don't pay it, well, it's like the old protection racket, where the boys would go down to some mom and pop store and say, yeah, you're very vulnerable here, and we're going to offer you this protection, but you got to pay us a certain amount of money per week. And Pop there is in this little story. He says, well, I've been here for 50 years. We've never had any problems. All the neighborhood is really nice. Everybody knows us. We're all friendly. And so that night, the store gets broken into, and it's all busted up. And the boys come back in the next day, and they say, well, Pop, if you bought our protection, this wouldn't have happened. And it's the old protection racket. And that's what SSL certificates are, in my opinion, to play it safe. But you make your own opinion. It doesn't do anything. It doesn't protect you. It doesn't, you buy it like candy. You could go into a store and buy a piece of candy. Here's 20 cents. Give me the piece of candy. They're selling SSL certificates like candy. They don't examine anything. They don't look at the web page to see if it's safe or not, or has Trojan hacking or anything else associated with it. And if you don't have it, if you don't have the SSL certificate, if you don't have that little S in the HTTP S up there, then this page comes up. They intercept it, and it says, don't go to this site. It's dangerous. It could steal all your information. It's terrible. It's horrible. Don't go to this site. And now it's universal, and this has been taken over by a couple large companies, which I'm not going to mention the names. Just go look it up. You'll find out who it is. But it's like highway robbery, in my opinion. And they are basically charging this exorbitant amount of money, in my opinion, for a service that is highly flawed, in my opinion. And like I say, now let's talk about the encryption that they use. They're using public key encryption. Well, public key encryption has been broken for ages. And like I say, the only real protection you have is because you are in a sea of other people using the internet, and you're not a big fish. You're not a big target. You're not a big target for hackers to go after. And so that's your safety, not because there's an SSL certificate on it. And like I say, the SSL certificate, you just go to your ISP and say, put the SSL certificate on this web page, and you pay a fee, and it's there. They don't check it out. They don't do anything. They just collect the money. Anyway, and so I call it, in my opinion, highway robbery. It's like the robber barons of old that would sit on the side of the highway, and everybody that came past had to pay a toll. And if you didn't, well, they robbed you. So, but anyway, the whole world of cybersecurity is questionable. The cybersecurity that's being sold to you, the public, has full of holes in it, and the hackers use the same backdoors as the security agencies, the government security agencies, that require backdoors in this software from all of the software companies selling encryption and firewall protection. And the hackers use the same backdoors so they can get into your computer. I could go on and on about computer security, but these are some of the main issues today, and I'd like to get more opinions out there. You can look up, and I'm not the only person that's giving this particular opinion. So you can check that out. But I think if more and more people would stand up and say, no, I'm not paying your security costs here, then this would have to go the way of the dinosaur. And there's really other protection that is very necessary, other layers of protection that are real protection. But that's a story for another day. We'll talk to you next week.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.